Alrighty, guys, let's go ahead and take a look at this next problem here. So it says, before becoming teachers, Mr. Shadell, 74 kilograms, and Mr. Weiss, 59 kilograms, used to be a ice skating pair, as you can see above. At one point in the routine, they would skate into each other and embrace. Consider the routine when they stick together if Mr. Shadell is skating to the right at 5 meters per second and Mr. Weiss is skating at a velocity of negative 5.5 meters per second. We're going to consider the rightward direction to be positive. So the direction that Mr. Shadell is originally skating in will be the positive direction. So let's start by identifying our data here. So first we have the mass of Mr. Shadell, which is 74 kilograms. That's going to be the same before as it is after. And then the mass of Mr. Weiss, which is 59. So 59 kilograms before and 59 kilograms after. Okay. So the next part, we're going to take our velocities. So before, Mr. Shadell has a velocity of 5, and Mr. Weiss has a velocity of negative 5.5. Okay. That is all the data that we have, or all the givens that we have at the moment. What type of collision is this? Well, it says that they skate towards each other and embrace, meaning that they stick together, which we can see right here. If they're sticking together, that's going to be an inelastic collision. So an inelastic collision, again, is when they are stuck together. So let's start by solving for our momentum in the beginning. So the momentum for Mr. Shadell in the beginning, so I'll write PS for, or PSCH for Mr. Shadell, is the mass, which is 74, times the velocity, which is 5. So all I have to do is multiply those two together, and I find out that his momentum is 370. The momentum for Mr. Weiss is the exact same thing, but with his mass, which is 59, times his velocity, which is negative 5.5. So I'll multiply those two things together, and I find out that Mr. Weiss's momentum is negative 324.5. So now that I have the momentums of Mr. Weiss and Mr. Shadell, I can solve for the total momentum. The total is just going to be me adding those two things together. So I get the momentum of Mr. Shadell, and I'll just write this out the long way, plus the momentum of Mr. Weiss. So now I'm going to plug those numbers in, and I find out that the total momentum before the collision is equal to 370 minus 324.5. Plugging those into my calculator, I end up with a momentum of 45.5. I know that the total momentum that I start with is going to be the same as the total momentum that I end with, so I'm just going to carry this over. And again, it's the same because conservation of momentum. Next, I can start filling out these boxes over here. So since they're stuck together, I need to figure out their total mass now. Their total mass is going to be the masses added together. So mass total is the masses added together. So that would be 74 plus 59. When I multiply those two things together, I end up with a total mass of 133. Now that I have the total mass and I have the total momentum, I can solve for the velocity of which they have when they're stuck together. So again, P total after is going to be equal to the total mass times the total velocity. The total momentum is 45.5. The total mass is 133, and the total velocity is unknown. So to solve for that, I'm just going to divide by 133, and I find out that the total velocity should be equal to 0.34. So here's the part where a lot of kids get stuck on it, and they say, okay, I know that, but like how fast is Mr. Weiss moving? How fast is Mr. Shadell moving? They're stuck together. If they're stuck together, it means that they have the same velocity. So Mr. Shadell's velocity is 0.34, and Mr. Weiss's velocity is 0.34. Now that I know their velocities, I can use that information to solve for their momentums. So the momentum of Mr. Shadell after the collision is going to be his mass, which is 74, times his velocity, which is 0.34. And the momentum for Mr. Weiss after the collision is going to be his mass, which is 59, times his velocity, which is 0.34. If I do that, I find out that Mr. Shadell's momentum after the collision should be 25.16, and Mr. Weiss's momentum after the collision should be 20.06. So 20.06 and 25.16. Again, we can see that there's a little bit of a rounding error here for the total momentum, but that's totally fine. It's just the fact that how we rounded or how the problem was solved in WebWork. Okay. One kind of bonus question here: what direction are they moving after they collide? Do they move to the left or to the right? Well, we can see that their velocity is positive, and since it's positive, we said that the positive direction is the rightward direction. So they move together to the right.